Hello. In air transportation, especially when we look at the operation of airlines, one of the most important cost consideration is the direct operating cost, abbreviated generally as DOC. So, today we are going to conduct a tutorial on estimation of direct operating cost. I hope you have already watched my lecture on DOC before doing this particular tutorial. If not, I will request you go and watch the lecture on DOC first and then come here. Although I am going to talk about the various terms of DOC here also, but it will be a good idea to get an overview of DOC before doing the tutorial. Now, in the tutorial actually we run through an actual case, do the calculations, and that is how we appreciate the various concepts. So, I am going to use a simple DOC model. There is no name for it because it was developed by me as part of my own research, and it is dedicated to only a particular class of aircraft called as the regional and commuter aircraft. So, I have recorded a separate lecture on what is meant by regional and commuter aircraft, what are their peculiarities. So, if you have not seen that, maybe it is a good idea to see that lecture first and then come here. So, essentially this is not a standard model. You will not find this model in textbooks or in any other standard document. This is just a method that has been recommended by me, which is being used by me for this particular class of aircraft. And again, it is limited within this class to only those which have got twin wing mounted turboprop engines. The reason for this is that one important aspect of operating cost, which are the maintenance costs, I have managed to get detailed breakdown of these costs for one particular aircraft of this type, twin wing mounted in turboprop engines aircraft, and I have used the numbers in that particular example, scaling them up and down for the engine and for the airframe respectively. So, therefore, it becomes relevant and applicable only for this special class of aircraft. Now, we are going to apply this model to look at operating cost of Dornier 228-212 aircraft developed by HAL Kanpur, an aircraft on which I have worked for about 3.5 years when I was working in HAL. So, I have taken the example of an aircraft which is familiar to me. We will use this model to calculate the DOC of this aircraft on a particular route. Okay. So, here is an overview about the total operating costs of the aircraft operation and an airline. They consist, as you know, of the direct operating cost and the indirect operating cost. Now, since this is a tutorial on DOC estimation, we are going to ignore the indirect operating costs. Generally, people take the IOC as a percentage of DOC. It could be 25%, 30%, whatever, but we will not get into that. We will look only at the direct operating cost today. The DOC can be broken down into three main subsystems. You have the ownership costs or the costs related to own the aircraft. Whether you own it or whether you lease it, the aircraft is under your jurisdiction as an airline. So, there are some costs associated with that. The next important term is the term costs related to the operating the aircraft, the flight costs, and also there are certain costs that you incur in maintaining the aircraft. When I say the aircraft, I mean the airframe as well as the engine. The cost of avionic equipment maintenance or communication equipment maintenance is considered as part of the airframe cost in this particular example. Now, under ownership costs, you have certain components. You have depreciation, interest and insurance. Under the flight costs, we have again some components. We have the crew costs, which are for the crew in the cabin and crew in the cockpit. That means the pilots and the flight pursuers and air hostesses in the cabin. Then there are expenses towards fuel and oil, which I am merging together as cost of fuel. And then there are some fees or charges levied by the airport's operating agency and the agency that provides navigation. In India, it is the Airports Authority of India. They are the ones who decide these fees for various aircraft types. And the maintenance costs, as I mentioned, are broken down into two separate subheads, the costs towards airframe and the cost towards the engine. So, we are going to look at estimation of all these cost terms for Dornier 228-212 aircraft on a specific route while operating in domestic routes in India, and also we are assuming that it is operating from small and new airports. The various components of DOC that are normally considered are as follows. There are standing charges, which are depreciation, interest plus insurance. There are crew costs, which are cost of cabin crew and the cockpit crew. Then there are fuel costs. Then there are maintenance costs, which are to do with the airframe and the engine. And then there are some airport costs or ATC costs, which are broken down into landing charges, navigation charges and handling charges or passenger handling charges. Some of these costs may not be applicable, some of them may be applicable only in particular scenario. We will see all that in our tutorial. Now, because it is a tutorial, it is expected that you, the listener of this lecture, is also going to do the calculations alongside my presentation. So, therefore, I am going to use a particular color scheme so that you can look at the color of the numbers and get an idea what these numbers come from. So, all the values which are specified, they are put in black color, and also the instructions are also in the black color. All the values which are assumed, they are in blue color. All the values which are to be calculated, you will find that I will put equal to and question mark signs, and I will put this pause button there. This pause button is a reminder for me to pause and also for you. So, whenever you see the pause button, you are expected to pause the video, do the calculations, get the answer, and then in the next click you are going to get the numerical value which I got, and you are supposed to compare that with your answer to ensure that you got the right number. So, that is why you will see whenever you see an equal to sign and 3 arrows, 3 question marks in red and a pause button, it is an indication to you that you have to pause the video. So, friends, if you do not pause the video and do the calculations yourself, this tutorial is going to be a waste for you, because I have seen over years by experience, only when you do the calculations yourself will you really understand the implications of all the various cost terms. So, I will strongly urge you to follow this scheme. The moment you see a pause button such as the one shown on the screen, you have to pause the video. On the left of the pause button there will be some calculation, numbers will be given, please do the calculations and then compare with the answers I got. The calculated values are going to be shown in purple color, okay. And in case there is a comparison, in this case we do not have any comparison, we do not have any data for what is the actual DOC, because that information is a commercial secret. So, we do not have anything to compare. So, we do not really, you will not see anything in green color. Whenever we do any calculations, we need some data, and the data has come from various sources. So, I would like to share with you from where I got the data for doing out this assignment. The data regarding the aircraft Dornier 228-212 has come from this website of HAL. There is a term called as the acquisition cost or the cost of acquiring the aircraft and its standard support equipment, that has been scaled up using an index called as PPI, about which I will talk in some detail. Then, as I mentioned to you, maintenance cost data I was able to obtain the breakup, the detailed breakup of maintenance cost from an operator which uses Dash 8 aircraft. So, since I know the cost for Dash 8 aircraft, I utilize that as a baseline and I have scaled up and the cost, scaled up or scaled down the costs of both the airframe and the engine in proportion to the data related to the Dash 8. So, as I will show you in the after few slides, I used this particular scheme to arrive at the maintenance costs. Then fuel price of course varies from time to time and place to place, also depending upon the quantity of fuel you buy. In our calculations here, we have taken the ATF price in Mumbai on 1st October, which was given by the Indian Oil Corporation as rupees 93.9 per liter of fuel. Of course, they sell fuel in kiloliters, but the cost per liter turns out to be on an average 93.9. Then the airport charges towards landing, handling and overfly or navigation, they are taken as per an AAI circular AIC 35-2020. This circular also mentions what will be the charges up to 2030. So, we have taken the charges applicable after 2025. Now, this particular link gives you the location of this circular. So, the RNFC, which I will talk in more detail, route, navigation and facilitation charge, which can also be called as navigation charges, TNLC, terminal navigation and landing charges, then there is landing charges and there is handling charges. All of these information has come from this particular website. Okay. Now, here is our aircraft Dornier 228-212 and these are the numbers which have been taken from various sources. The base price of the aircraft is taken as $2.8 million US in 1996 and it has been accordingly scaled up to the present day values. Okay. And I will show you how it is done. We have assumed the aircraft, we have taken the aircraft maximum takeoff weight to be 6200 kg and airframe weight to be 3178 kg and the power plant per engine propulsion engine SFC to be 715 horsepower and we operate the aircraft with 2 crew members and we are assuming a particular route where the stage length is 250 nautical miles. So, the calculations will be done for a stage length of 250 nautical miles. Now, let us look at the first important requirement is to get the block time and the block fuel data. What is block time? I have explained in my presentation regarding the DOC that block time is the time from chocks on to chocks off when the aircraft arrives. I am sorry, it is chocks off when the aircraft starts moving till chocks on when the aircraft is brought to the rest at the destination. So, total time taken by aircraft in taxi out, takeoff, climb, cruise, descent, landing, taxi in and stopping, all that time total is the block time and the fuel consumed in this entire segment is called as a block fuel. So, the block time and the block fuel data has been taken from this website for Dornier 228. Information is available for 4 stage lengths, how much time does it take in minutes and how much fuel is consumed in kgs for these 4 stage lengths. This information was plotted, it is a straight line, so that can give you an equation and from that equation you can say that the block time in hours is a function of stage length and there is a constant term. So, this constant term of 0.1533 is approximately 9 minutes, 0.15 into 60 and that 9 minutes essentially is the minimum time that is required even when the stage length is 0. In other words, this can be taken as the minimum time required for the maneuvering of the aircraft. Here is a graph for block fuel versus stage length. So, even here you see that the equation says that 54.35 kg is the fuel required even if you have 0 stage length. So, therefore, 54.35 kg can be considered as the maneuver allowance or the fuel required for taxi out, take off, landing and taxi in. Okay. So, that is the minimum fuel will be consumed in every operation. So, we will use these two formulae to calculate the block hours and the block fuel. Now, let us start with estimation of the acquisition cost of the aircraft, and for this we will use a term called as a producer price index or PPI for aircraft manufacture. Remember, we have assumed the cost to be a particular value in 1996, right. So, we have to get the number which is applicable to 2025. So, if you look at the data from Federal Reserve Bank, now I am going to do all the calculations in US dollars, although we are operating in India, but we are going to look at US dollars as our baseline currency for the calculations, and in the end we will convert that into the Indian currency. So, the producer price index in 1996 was 140, and this number has become 296 in 2025. So, therefore, if we assume that the aircraft cost is $2.8 million in 1996, when you scale up the price, you will find that the acquisition cost of the aircraft in present year turns out to be about $6 million, to be precise $5.92 million. So, what was costing $2.8 million to acquire in 1996 will cost around $6 million to acquire in present times. So, this is how we get an idea about the approximate acquisition cost of the aircraft. Now, the first and the foremost element to be calculated are the standing charges. You know that these are charges which are incurred even if the aircraft is just standing and not flying. They consist of three major terms: the cost of depreciation, the cost that is a loss in the value of the asset, which is the aircraft and its various important support spares due to the passage of time. Okay. So, as time progresses, the value is lost. The second one is the insurance cost. This is the cost towards payment of premia for the hull insurance, for the crew insurance and the passenger insurance. This also has to be incurred by the airline. Whether they are flying or not, they need to take care of the insurance, because the moment they fly, they will have to anyway take care of these expenses. And the third important component of standing charges is the interest. Interest is basically the financial payments to be made by the airline for taking the loan to procure or to lease the assets which have been required, or the aircraft in this case. When I say aircraft, I also mean the associated minimum spares which are required with the aircraft always. So, the standing charges are going to consist of depreciation, insurance and interest. Now, there can be various formulae for these estimating these numbers. I will show you one by one. But before we are able to decide the depreciation, we need to realize how many hours we are able to fly, that is U annual, and how many flights we are able to do on this particular route of 250 nautical miles if we use the aircraft only for this particular route. So, here is your first calculation. So, if the stage length is 250 nautical miles, we need to calculate what would be the block fuel required, how much fuel will be required for operating one flight of 250 nautical miles. So, please do the calculation, the numbers are in front of you, 0.1533 plus 0.0054 times 250. What is the value? Please take a pause here and calculate. The value turns out to be 1.503 hours. So, this flight has a block time of 1.503 hours, nearly 1.5 hours, 90 minutes flight. Then we look at the annual utilization. Suppose this aircraft is being used only for this particular route, which is 250 nautical miles, then we need to estimate what is going to be the annual utilization. Now, analysis of data has shown that for small aircraft like these, the total time, the total number of hours you can operate it is only about 3600. Okay, that is the maximum you can aim to achieve. So, assuming we are able to get the maximum, the annual utilization is equal to 3600 times T block upon T block plus 0.5, where 0.5 is the turnaround time, the time between two flights required for activities such as deboarding the aircraft from passengers, putting in the various consumables that you have to provide, and maybe cleaning the aircraft, okay, and also in unloading the baggages, loading the passenger, all that required some time. Now, we are assuming that it is an efficient airline operation, and therefore 30 minutes are more than enough for this. Perhaps it can be reduced. Some airlines are able to bring it down to 20 minutes, 16 minutes also, but let us go for half an hour. So, therefore, if the aircraft is used for this particular route, which is 1.503 hours long, and half an hour is required for turnaround time, then the number of hours you can use in a year are given by this equation. And take a pause here, do the calculation, and then match your answer with my answer. So, please take a pause and do the calculations. Okay. Coming back, so I get the number as 2701.3 and I ignore that 0.3 and it will be 2701 hours per year. So, our aircraft can be used for 2701 hours per year for operating on this particular route. Then how many flights can you operate? Because each flight is 1.03 hours block time and total number of hours is 2701. So, how many flights can you operate? You can get it by dividing the total number of hours 2701 divided by flight time of each hour or block time of each hour. Please do the calculation. The answer comes out to be 1797.3. Again, I ignored that 0.3. So, therefore, we are able to do approximately 1800 trips per year. Okay. This is a very high number actually. The real number for number of trips per year could be little bit lower, but it is also a function of the block time, it is also a function of the turnaround time. But for example, we will take 1797 trips per year for our aircraft. Alright. Now, we look at the cost of the equipped aircraft, that means aircraft with certain minimum support items which are needed for it to operate. So, C equipped AC is the cost of the equipped aircraft in US dollars. So, here we assume that 80% of the acquisition cost is towards the airframe and 20% of the 80% of the distribution is towards the airframe and 20% is towards the power plant, right, where you have the spares factor. Now, when it is 0.8 times the airframe, then you require the airframe cost plus the cost of the spares. So, we assume here that 15% additional spares are required for the airframe, and we also assume that 35% additional spares are required for the power plant to operate. So, we will be buying them and we will be putting it with the aircraft. That will be a package that comes, aircraft plus these essential mandatory spares. Okay. Now, this is an assumption based on certain suggestions given based on the industry practices. This number could be up and down in real life, but we have to take some number at least. So, assuming that to be the number, now $5.92 million is the scaled up price of this aircraft in 2025, and with that you can see that you get this equation. So, now I would like you to please calculate and then tell me what is the cost of equipped aircraft that you get. As per my calculations, the number comes out to be 7.0448 million US dollars. So, each of these aircraft with some mandatory support components is going to cost around $7.45 million to the airline. Right. Now, we look at the estimation of depreciation cost, C depreciation. Now, depreciation is basically given by this formula. The aircraft that we have purchased at this $7 odd million, it will have some residual value at the end of its life, which is F life, right. So, the F life of the aircraft is assumed to be 15 years because we are using it to fly almost 1800 trips in a year, we are assuming that in 15 years the aircraft is going to be completely written off, but because it is metal and it is having lot of material which can be recycled, we are assuming that 10% of the original cost you will be able to recover by the resale value of the scrap. So, that is why the residual value of the aircraft is assumed to be 0.1, right. So, therefore, the depreciation cost will turn out to be this particular expression, and I would urge you to calculate. So, the aircraft flies 1797 trips in a year for 15 years, and at the end of 15 years it has got only residual value of 0.9 because it has got a residual value of 0.1. So, 0.9 of the aircraft is consumed. So, you multiply with the cost, you will get the depreciation cost. This cost is turning out to be $235.22 US per trip. So, per trip the aircraft depreciates by so much amount. In every trip of the aircraft cost aircraft value is reduced to reduced by this amount in every flight. Okay. Now, let us look at the estimation of interest cost, the second term of the standing charges. So, here we assume that the aircraft is procured using 10% interest, and half represents the book value of the aircraft. The book value, I am just assuming that at any given point of time it is like 1 plus 0 upon 2. So, half of it. So, therefore, the 7.048 million US, they will have to be taken up at 10% interest from the market, and if you divide that by the number of trips per year, you will get an idea about the interest costs. So, that comes out to be rupees 196 US per trip. Okay. Now, the term half takes care of which particular year, because we are doing this over 15 years, right. So, therefore, we are saying that over 15 years, assuming that the book value of the aircraft is half of the total cost, we just depreciate that, we just take the interest of that over the number of operations per year, which is 1797. So, the number comes out to be 196.02 US per trip. And the last term of standing charges is the insurance, which also is taken on the basis of the insurance premium. That premium depends on many factors. It depends on your claim history, where are you located, do you fly during tropical conditions, monsoon, or in calm conditions, what kind of operations you have short haul operations or you have operations on prepared runways, maintenance standards you follow, what training, there are many factors. So, all that decides. We are assuming that for a commuter and regional aircraft operating on short haul operations, there will be a 1% insurance premium charged. Okay. So, therefore, the cost that has to be borne by the airline per every trip would be on the book value, which is half of the total cost. We have to pay 1% interest, and that comes out to be $19.6 US per trip. Therefore, if we just add these three charges, you will get the standing charges: depreciation plus interest plus insurance. And these three numbers have already been obtained by us in the previous few slides. So, now what remains is just an addition. So, here I would like you to take a pause and calculate the standing charges. It comes out to be $450.84 US per trip. So, with this we have now come to the stage where we can estimate the standing charges.